Alrighty, everyone, we just got it okay to start our planetarium show. So I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter, and I'm very excited to have y'all here for the last planetarium show of the day because this whole show that we're about to see is different from all the other ones that we've done here in the Morrison. This one's called Tour of the Universe, and this show is completely live, so you're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis or where we are in space. But just a heads up, we're pretty small in the grand scheme of things. Also, everything that you see in purple right now is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. But before we get started with our show, folks, I do need to go over some quick house rules just so that we're all on the same page and have an enjoyable time. First off, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater nice and clean for all the guests coming in today. We do appreciate your help. And also, folks, if you have any cell phones or smartwatches, now's the time to put them away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. If you need to exit, the exits are going to be at the top of the planetarium, so always make your way up the stairs. If you have trouble climbing the stairs, don't worry, just remain seated. Once the show's over, we'll have someone escort you to a lower exit as the show's wrapping up. And folks, if at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to help you. All you got to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco. But otherwise, folks, it looks like we're ready to go. Just waiting for those last few phones to get put away, and we'll start our tour of the universe. All right, that fellow will keep looking at maps. We're going to get started with our tour of the universe. Alrighty, everybody. So we're going to be starting off our tour of the universe pretty close to home. We can see just the curvature of our planet just down below. But we're starting off at this thing right here called the International Space Station, or what we like to call the ISS for short. And a lot of people tend to ask me, hey Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct all sorts of science experiments up here, much further away from our planet that has less gravity. Some of the experiments that they'll conduct are things like what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently? Which way do the roots grow? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also tend to lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also, folks, this thing is going incredibly fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this also looks really far away from our planet Earth, but it's not that far either. The International Space Station is about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So not too bad. But folks, this is as far as we put humans into space nowadays because traveling into space is quite costly. You gotta build yourself a rocket ship or buy yourself one. Then you have to get a lot of rocket fuel. And then you have to account for all the food, water, all the air you're gonna be breathing while you're up here in space. So the bill can get quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. And now we're gonna see it slowly disappear to the city lights down below. It looks like we're just above India right now. And before we lose track of it, I want to add a nice little orbital path so you can see where we are, where it is as we're slowly fading away from our planet Earth. Alrighty, folks, we've zoomed so far out now, we're able to see our entire Earth in its entirety. And I want to let you know that the space program that I'm using here is something that you can go home and download if you like. The space program we're using is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link where you can download this. And it's a whole lot of fun. But just a heads up, OpenSpace uses a whole lot of processing power, so if you have an older computer, you may want to rethink it because it takes a lot of processing power and it takes a lot of memory as well. But if you got something new like a gaming computer, give it a try, it's a whole lot of fun. But if you're a person like me that doesn't want to download anything, you can also use another alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you'll come across a link where you can fly through space without having to download anything. But in here, we're using OpenSpace Project. But now that we have a nice sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Alrighty, folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun as well. They got to play some golf up here. But again, last time we sent humans to the moon was 1972, so a little more than 50 years ago or so. But don't worry, folks, NASA has a new space mission in the works called Artemis. And pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. What's really cool is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to do a lot more science in a much more compactable size. And we want to do different science experiments, and again, eventually get humans to Mars. And one place that we want to set up a lunar base is going to be the south pole of the moon because we found ice there. And ice is very helpful because you can melt that ice, pass electricity through the liquid, and you can get hydrogen and oxygen. Both of these are very valuable when you're really far away out here in space. But again, folks, we humans should be heading back to the moon in the next few years, so crossing my fingers, look out for any news about Artemis. And folks, when you look up at the moon here on planet Earth, the moon sometimes looks really close to the Earth. Feels like you can reach out your arms and touch it. But the moon's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. and light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. We'll see you later. And now, folks, we're going to be leaving the Earth and the moon's orbits behind. And now we're going to be making our way out to a much larger realm of our solar system. And before we lose the moon and our Earth, I want to add some nice orbital paths so we can see where everything is out here in space. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now, folks, the nearest star to us, the sun, comes into view. So here comes the sun. Do. And folks, the sun is also incredibly far away. It's about 93 million miles away from the Earth. 93 million miles. That's a good distance away. But in terms of speed of light, that's not too far. In order for sunlight to travel all the way to the Earth, so we're the third rock from the sun, we got 1, 2, 3, that's us. Only takes sunlight about 8.5 minutes at the speed of light to get to us. So not too far away in terms of speed of light. But what's really cool is if the sun was to turn off all of a sudden, that last bit of sunlight would take 8.5 minutes to travel that 93 million miles, and then all of a sudden the daytime on Earth would become nighttime. And this is a really cool concept to grasp because when you look at really far away objects in space, the deeper or further you look, let's say we're looking at a star that's 70 light years away from us, we're seeing that star as it looked like 70 years ago because that light that just reached us took 70 years to get to us. So when you look at really far away objects, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what's here. Right in the middle, we have our sun, the biggest thing, our star, and then the closest planet to the sun, we've got Mercury, then we have Venus, then Earth, that's us, and then we also have Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all the asteroids in our asteroid belt. There is a lot of them. And then past the asteroid belt, we have the really big planets. We got the gas giants, the Jovians. We got Jupiter, the largest of them all. Saturn, famous for its rings. And then now we have our icy gas giants. We got Uranus, the funny one, and Neptune on the very left. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So the Kuiper Belt's like a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets. Comets that don't stray too far away from the sun. And what's really neat is that we came across the Kuiper Belt in 2006 because our technology improved, so we're able to see much smaller stuff much further away. And in 2006, we found more than 400 objects out here in the Kuiper Belt region. And that's why everybody on Earth, the astronomers, came together and had to reclassify what exactly a planet is. And during that meeting, they came up with 3 different criterias, and that was the day when Pluto got kicked out of the Planet Club and became a dwarf planet. Because again, there's so much stuff out here. Some of that stuff was bigger than Pluto. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And I want to put that away. And now I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, folks, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad either. But folks, it's now time for us to leave our planetary scale behind, and now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is going to be on the very top left of our screen. So again, right in the middle is our solar system right there. We're zooming back towards it. Alpha Centauri is the closest one to the top left. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Folks, if you're getting a rocket ship today, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that distance. Whew, and that's just a one-way trip. But let's stop consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that. But the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. But is anybody out there listening? And now, folks, I'm going to be adding some markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because our space telescopes are constantly scanning the night sky, so that 5,000 number is going to be going up. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. New space telescopes are being developed right now, so they're on the drawing boards. They got to be constructed, launched into space, so we got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system somewhere inside the radiosphere. Let's say on the left-hand side right over here, we find an alien civilization somewhere on the right-hand side on the other side. Let's say this. We shoot them a text message. We say, hey, we're humans. We live here. Takes 60 years to get to them. They listen in, answer back. Another 60 years to get a response. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. And I also don't think I can live that long. But of course, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Alrighty, everybody, we're now looking down at our Milky Way Galaxy. This is the galaxy that we live in. And I've got to ask, can anybody see their house from here? Nah, we're way too far away. But our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance away. And not only that, our Milky Way Galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way, I want to show you what it looks like from a sideways perspective. You're going to notice that the Milky Way looks like a big flat pancake. It's a big disk, big flat spiral disk. And you probably heard someone say while you're camping, hey, look, you can see the Milky Way from here. What they're talking about is this, the plane of our Milky Way. That's what you see up in the night sky. And this is important because when astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, it's easy for everyone to learn about the universe by looking galactically north and galactically south. Keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So now in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue expanding out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, they like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies, or voids where there's no galaxies. So we can see some nice galaxy clustering over here, some over there as well. We can see very few galaxies towards the top of our planetarium dome. You can think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at represents the closest 30,000 galaxies to us in space, over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brantoli, who compiled this amazing representation at the University of Hawaii and worked beside dozens of other astronomers over decades of time. So big shout out to Dr. Brantoli. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew. And also, folks, I just want to let you know that the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of our Milky Way? If you were to line up our Milky Way plane, it would line up and down just like so. So again, we like to point our telescopes galactically north and galactically south. Now, astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so they did a quick survey, these purple dots that you see there. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been filled in yet. So it's just a matter of time. And unfortunately, folks, it looks like we're running close out of time, so we got to continue pressing on. And now we're going to be encountering these really distant, far-away objects known as the quasars, which are going to be represented by orange dots at the very edge of the large-scale structure of the universe. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. And so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, everybody, here we are at the very edge of the observable universe, and what we're looking at is called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. Now, this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny small differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And this looks like a good spot right here. And let's make our return trip back to planet Earth, everyone. All right, everybody, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their pair of telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight through that radiosphere, making our way back to our star system, our solar system. And now, folks, we're passing those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now, folks, it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And it looks like we're making our final approach back to planet Earth. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back safe and sound just in time for dinner time. But with that being said, that's all for now. Thanks for stopping by, everybody. I hope you had a good time.